Okay guys, now on to page 3 and 4 of the electrical schematics, where we're going to be working through the boilers. So page 3, we got boiler 1 there, and then page 4, we got boiler 2 here. The operation and the wiring is exactly the same. The only slight difference is how the layout of the connections is on page 4 to page 3, but it's exactly the same. The only reason the connection points are shifted on the drawing is just to make it a bit neater with this 0 to 10 volt control signal. So with that being said, we're going to be working through boiler 1 on page 3 because it's exactly the same principles on page 4 boiler 2. So first of all, what is the design goal, the outcome, the philosophy of this page? Again, you find all this out through reading the spec, which can be found in the reference documentation and the reference folder. But ultimately, we want to be powering on the boiler. We want to be taking a fault output and an enable output. We want to be controlling it intelligently through a 0 to 10 volt control signal. So not on and off, but through modulation. So adjusting the temperature based on the demand of the rest of the system. So the demand of all the rooms within that school. So quick example, give you an idea of what I mean by demand and the amount of demand. Let's say it's the middle of winter and we've shut up the school overnight, and then we've come back in the morning, and we need to get all the rooms within the school to a certain temperature quickly for a certain amount of time. Now, it's most likely that both boilers are going to fire up and go max 90-degree heat to get a lot of heat into those classrooms and all of those classrooms as quickly as possible, and then they'll probably settle down a bit. But then let's contrast that to a similar scenario, but in the summer, and maybe some rooms are already at temperature in the morning and sufficient and comfortable for the kids and the teachers, but maybe there's some rooms that are sort of out of direct sunlight, maybe in the shade, that are a bit colder, and it's just a few of those rooms. Then we might have the boilers fire up maybe at, 30 degree, 40 degree, 50 degree heat, because that's going to be enough to achieve that temperature in whatever time frame's been decided. So that just gives you a quick idea of what I mean by demand. So let's jump in, and I'm not going to go through the power section because that's the same in every page, and we've already been through that a couple of times. So let's jump straight into the controls. So the first thing to look at is our enable signal and fault signal. So we're coming off that 24 volt AC supply from the transformer, and we're tapping off that, and we're going via terminal block 21, and then we're going into the boiler, but actually we're going into that third party OEM module that we've connected to give us the ability to capture the enable output and the fault output. So on that unit, the supply is L, and then the output for the enable is QX21, and for the fault it's QX22. Now, it's not 100% clear on the tech manual, and I didn't go as far as asking when I was on the phone to tech support whether these contacts are normally open, normally closed. It sounds like they're working in the orientation of normally open, where we need to use the normally open contact, but it doesn't give us an option, but I'm imagining it's operating in the normally open philosophy, mythology, whatever you want to refer to it as. So let's presume that's the case, and we'll look at the operation, and then we'll have a look at what we'll have to do if it's operating in a normally closed philosophy or mythology. So that's our normally open contact for the enable signal. Now, when the boiler is enabled, and let's just for argument's sake say that it's enabled when power is going to the boiler. So when that happens, that contact then closes, and then it allows that 24 volts to pass through the contact back into our system on terminal block 20, go to relay 4, and it energizes that relay. Then let's have a look at what's happening on the contact side of relay 4 on pole 1. So what's happening is we're also tapping off the 24 volt supply, and we're going into the common of the first pole on relay 4. Now we're not, as you can see, we're not using the normally closed contact on this relay. We're only using the normally open. So because that's now energized, that contact's closed, which allows that 24 volts to flow down here and bring on that enable light. Now let's do the same thing for the fault output. So same thing, 24 volt supply going out on 21, going into the boiler or that OEM module. Again, we're wiring this normally open. Now, when that then goes into fault, that contact closes like that. 24 volts flows through it, back into 22, and then energizes relay 5. And then similarly to relay 4, we're not using the normally closed contact. We're only using the normally open. So common, normally open. So that then closes because the relay is energized, which then allows that 24 volts to go off to that fault light. Now let's just suppose, just so you can see how things need to be switched round and inverted if things aren't sort of designed as the piece of equipment in the field works. So let's just like reverse things and see what we need to do if, rather than what I originally said, where these are operating normally open, let's say that they're operating in a normally closed methodology. So let's just work through the enabled side for this example. So it's operating normally closed. So that contact's normally closed like that. So the boiler's powered up. That's enabled it. But what that means is that then switches that contact from normally closed to open. And then what happens, or at the same time, what happens is we're taking that 24 volts via 21, and then it's not getting any further than there, which means that this relay is not energized, relay 4, which means that this contact doesn't close there. So it's open circuit there, which means that this 24 volts doesn't get any further, and it doesn't bring on that enable light. Now that's a problem. Things aren't operating as they should. So how do we rectify that issue? So the first and most simple way to rectify that, so let's just rub this out. The most simple way to rectify it is if we have got a normally open contact, we then just wire this cable here to the normally open contact. And then that will just operate in the same way as we just went over a second ago. But that's not an option on this module. So that's staying as normally closed. So let's just go through that again quickly. So we got our 24 volts and then it's going here and it's connected normally closed. Then we power up our boiler. It's enabled. That enabled signal changes. So that then goes open, which doesn't help us as things are wired and configured at the moment. So what we need to do is we just need to switch things around the other way. So this isn't energized. That's fine. All we need to do over here on the contact side is we can still use the common. So this cable here is still wired into the common with the supply voltage, the 24 volt supply voltage. So yeah, now we've just rewired that wire to the normally closed contact, and then that 24 volts is then able to come down and then power up the enabled light. And then let's have a look at it reversed. So there's no longer any power going to the boiler. which means that this contact here then closes. So 24 volts then flows through and then energizes R4, which then opens up this normally open contact like so. So then that will go open circuit, and then not allowing any 24 volts to then enable this light. So we're doing the same operation just through changing where that cable is wired to, and ultimately changing what that contact looks like in the system and in the drawing. So we're just switching it from using the normally open to the normally closed. And that's how we would get around that issue if that was an issue when we got to site. So that's the enable signal and the fault signal covered. Now let's have a look at the next thing along. And this, you can see, is tapping off the boiler interlock circuit. So when is the boiler interlock circuit enabled and healthy? So if we go back upstream on the drawing, that's the pressurization unit is in a healthy condition and the gas detection system is in a healthy condition. So when those conditions are healthy, that means we've got a supply on that boiler enabled or boiler interlock circuit, which we're then using for the control of the boiler. And we're going to go through that now. So what you've got here is a 3-position cam switch. So if we jump to the images here, you can see that this is what it looks like. We've got the standard off position, we've got a hand position, and we've got an auto position. And this is just a standard naming for BMS panels. Hand is manual, off is off, obviously, and then auto is having the PLC or control system take over and control it, basically. And then you can see here on the other side of the door, we've got that same cam switch. So when it's in the middle position, the off position, neither of these contacts are engaged. And then when it's in the hand position, this, as you can see, NO, normally open, and green represents normally open on these contacts. Red represents normally closed. So you can see they're normally open contacts. So if we switch that to hand, this is our interlock circuit, the 300 circuit. Switch it to hand. That closes and then sends power, 24 volts in this project, down the 106 cable. Just a quick one. Sorry to interrupt, but this video that you're watching right now is actually a lesson taken from our new training program that's coming out this Friday. And if you wanted to master the first steps in controls and automation, giving you a very solid foundation, enabling you to feel more confident in working in control panels, working with systems, understanding relays, contactors, PLCs, and how they all work together. Also enabling you to fault find and diagnose systems far more efficiently, and even the ability to start designing your own control and automation systems across any industry. Then if that sounds good, click the link in the description right now, and I'll make sure that I send you the other early access free training videos coming out this week, and I'll let you know when the program goes live on Friday. So let's do that. We've physically switched that cam switch now from the off position to the hand position. Like I just mentioned on the image, that now allows the 24 volts to go across there and then down on that 106 circuit. And then what that does, if we continue, it goes down and energizes relay 6. And then we can see the contacts for relay 6 are over here. So now both of those contacts, and this is one of the only relays where we're actually using both poles, pole 1 and pole 2, to do some electromechanical control. We need both of them in this example, or for controlling what we're controlling here, the boiler. So that energizes that relay and it closes both of those contacts. Now let's have a look what's upstream from those contacts. And we can see here, we've got our 10 volt power supply, 10 volt DC power supply. And we've also got MCB7 which is feeding that power supply from the 230 volt AC supply. And we've obviously got a neutral as well. So providing that's powered, that's then converting that 230 volt AC to 10 volt DC. And it's actually an adjustable power supply. So we can adjust whether that's 10 volts, 9 volts, 8 volts, 2.5 volts, whatever you want. And I'll show you that in a second. But let's just say it's 10 volts for the time being. So before those contacts even closed, that was allowing 10 volts to get to this point here. It's also doing the same over on page 4 to the contacts that are being used in this same way. We're just spreading that supply over to the other page, as you can see on those cables that we just highlighted and those arrows pointing over there. But we don't need to go into that. It's the same thing as what we're going through here. So now, because we've energized R6 from switching the cam switch to hand, which is our manual override control, that then flows down here. This is the 10 volt side, and then via terminal block 24 and then into H1, like we looked at in the tech manual. And at the same time, we've got the 0 volt DC side doing exactly the same thing via terminal block 23 and then into the ground of that H1 input. Now, what that's doing, when that cam switch is in hand, that power supply supplies this boiler with whatever we've got that adjustable power supply set to. In this example that we've just gone through, 10 volts. And then if we go back to the tech manual again, what does that 10 volts represent? It represents a temperature output of the boiler. And if you remember, we're using the boiler at its full capacity. So that now equals 90 degrees C that the boiler is firing out when we've got it set in hand. So let me just show you images of that power supply that I was talking about. So here it is from Foxtam, little orange thing. And as mentioned in the drawing, it's adjustable. So this has got a little like potentiometer. So we can adjust how much this power supply is giving out. So 10 volts, 6 volts, 2 volts, etc. And then you can see here coming out on the DC side, I'm then feeding that into a couple of terminal blocks just to make the wiring a little bit easier. I didn't necessarily have to do that for this panel, but I just think it makes it better and easier to maintain, fault find, service. It's all very clear. So yeah, that's what I've done. So on the positive 10 volt DC side and the negative DC side, you can see the numbers of the circuits here. I've also earthed the 0 volts, which we'll get into in another lesson. Now, what we could do is perhaps if someone puts the boiler into hand, we don't necessarily, when it's in manual mode, want the boilers to be firing up at full pout, giving out 90 degree heat, which might not be a good idea, might not be necessary. It's going to burn a lot of fuel. So what we'll probably do is set this back to maybe 7 volts, 6 volts, which I think correlates to, sort of 60, 70 degrees. So the boiler's not having to work so hard and burning lots of energy to get up to 90 degree heat. So we set that now to say 60 degrees C and 6 volts. So this is now set to 6 volts. And let's just imagine what we just went through. Cam switch set to hand, those close. And now we've got 6 volts being supplied to the boiler, which then correlates to like something like 60 degree heat. Now, let's have a look at what happens when we switch that cam switch to auto. So we were in hand, then to switch it to auto, we've got to rotate through the off position. So 6 is no longer energized. So these are now in their opened condition and normal state. And then we're switching to auto. So let's have a look at what's happening now. So again, we're using that boiler interlock circuit supply, and we're going through that contact. Cam switch is set to auto, and then we're going down on this cable now and feeding that to R7, relay 7. So that's now energized. Now we can see the contacts for R7 right here next to it, and they're operating in exactly the same way as what we were doing for relay R6. So now both of those contacts have closed, which is allowing now whatever's connected over here, which we'll have a look at in a second, is allowing whatever's coming out of here to go down here and here via the two terminal blocks and provide the boiler with that 0 to 10 volt signal. So exactly the same thing is happening. All we're doing is we're changing where that signal is coming from, where that voltage is coming from. So in hand, it was just coming from the power supply and whatever we set that power supply to. Now in auto, let's have a look at where that goes. So page 11, D117. And just to point out, these arrows, just like all the other arrows that we've looked at so far, they're just pointing towards the cable, the physical cable is going. That's not the flow of electrons or current. That's pointing to where the cables are going. Just like we're doing up here with these cables and over here with these cables and over here with these cables. That's all it's doing. It's indicating that they're cables going in that direction, and that direction is page 11, D117. So let's have a look at page 11 now. Here we go, page 11 there, and we can also see it because it's 1111 over here. So we're on page 11, and the reference was D117. So D117. So let's join up those references now. And yeah, it takes us to where we want to go. So now, if you have a look at what it says here, this is now referencing that these cables are going off to page 3, C35. So let's have a look at that. So we're on page 3, and we can see it here, 333. And it said, I've got a memory like a goldfish, but I'm pretty sure it said C35. So let's join those up, C35. And look, it takes us back, straight back to where we've come from. So that's what's happening there. It's just showing us, because we can't necessarily draw everything on the same page. So when something is on another page, we need to reference where that thing is. So as you can see in this example, we're going off to page 11, D117. So when we get there, we find out where that location is, and then that just references straight back to where we were. Okay. So now on page 11, D117, let's have a look at what those cables are doing and where they're connected. And you'll also see, if you look closely, these cable identification numbers are the same on this page as they are on the other page, just to show that we're using the same cable here. If they were different cables, they'd be identified differently. Now, first of all, let's just go over what this box is. And ultimately, this box is a PLC, or a PLC module. And this module is a 0 to 10 volt output module. And the name of it is a Zenio mini box 0 to 10 times 2. So Zenio is the manufacturer, and Zenio manufacture hardware that uses the KNX control protocol. And if you want to learn more about this module, the tech manual's in the resources folder, but we're not going to go into all the detail of this specific module, because what we need to know for the schematics is that it gives out a 0 to 10 volt control signal. But ultimately, we can just think of all of these boxes on the later pages just as a PLC. they're just control modules. Now, what's coming out of output 1, and we've got 2 connection points, V1 and F1. You can see that there's a negative and a positive. So it's pretty safe to say that V1 is like the ground or the 0 volts, and then F1 is like that variable voltage. So 0 to 10 volts coming out of here. So that's our 0 connection, cable 163, and this is our variable 0 to 10 volt connection, cable 164. And you can see that those cables are going back to where we just were. So let's just go back there, and then I'll finish off talking about that control module. So back to where we were, and those cables are coming in here. Let's use another color. So those cables are coming in here, and you can see closely 163, 164. And yeah, because R7 contacts are closed, that's allowing that PLC module now to determine the control going to the boilers. So let's just recap what we've just gone through quickly, just so you can see everything all in one, relating to the PLC control, and then I'll get into a bit more detail about how the PLC works. So we got that boiler interlock circuit that's feeding our cam switch, currently in the off position, and then we're switching that on the front of the panel to auto. And we've got the 24 volts traveling down here, going down here, and then powering up and energizing relay 7. So what that does is it closes these contacts. And just to point out, R6 relay is not energized, so these are open. So there's nothing coming back up here. And then from that PLC module now, we're allowing the signal to come from there. We've closed those contacts, and that's allowing that control voltage to now come from the PLC via our terminal blocks and into our boiler. Now, the voltage provided by that PLC is not constant. It's not the same as whatever's set on this adjustable power supply, like we went over a second ago. This will change. So it might be 0 volts, it might be 2 volts, it might be 10 volts, it might be 3.3 volts, it could be any voltage. And what determines that voltage is the programming. So now we're relying on the programming of the system to determine, what goes into that boiler and how much it heats up or how much it cools down and what temperature it stays at, when it switches on, when it switches off. And that's all done on the programming of the system, of the module. But ultimately, that's going to be determined by, as mentioned earlier, the demand of the system. So the classrooms within the school. And then if you look on the hydraulic schematic, there's some temperature sensors dotted about, depicted with the letter T. And that's going to be sort of monitoring flow and return temperatures on the system and determining whether to bring the boilers up or bring the boilers down. And this is what's known as a PI loop or a PID loop. So that's ultimately what's happening when we're in the auto side of the cam switch for the boilers. Now, like I mentioned, we're not going to go through it on page 4 because it's exactly the same operation. But what I'm going to challenge you guys to do is to just go through what we've been through on page 3, but apply those same principles and follow through with a pen or a highlighter where the cables are going and how the circuit is functioning in the same way that we did on the previous page, because it's slightly different. Things are laid out slightly different, but it's all exactly the same principle. So that's what you should do before moving on to the next lesson. Before you do that though, let's just quickly run through some images referencing the PLC side of that control. So first of all, we've switched the cam switch to auto, and then that sent 24 volts to this cable here, energizing R7 on A1. So the coil side. So that's now energized. And then we've got pole 1 and we've got pole 2, and they're in the normally open configuration. So that's energized. Now both of those contacts are closed. So firstly, let's have a look at where 164 and 163 go. So as you can see, that Zenio module, and we've got the same identification here as what's on the drawing, and we've got our terminal 1, and it has 163 and 164. So those are our feed cables sending that variable 0 to 10 volts to that contact. So that's the feed or the supply, and there you can see they're feeding in there. And because that relay is now energized, that's allowing those feed cables to then feed through the contact and out on 166. And you can't see this one, but this is 165. And then those terminals go off to the terminal blocks. And those terminal blocks are 23 and 24, which you can see here. So 116 and 165. And then we'll have our field cables connecting in here and going off to the boiler. Just a final reminder to click the link in the description so I can send you those early access free training modules from the program that's going live this week.